In the last video, we talked about our desire to calculate the area under a curve, a shape where part of the shape was a curve that we knew the values of. And what we're going to do for the next bunch of videos is we are going to see at least how close we can get using the amount of math we knew before calculus to give us at least an estimate and something that we can evaluate and see if, if it's something that we can make use of with our new calculus knowledge. All right, so here's the curve we're going to be talking about for quite a while. This is a curve bounded by the x-axis, the lines x equals 1 and x equals 7, and this parabolic curve, which has an equation of f of x is equal to negative 1/3 x squared plus 2x plus 5. All right, and so here's the idea that I'm going to start with. I can't find the area. I don't know any formula for finding the area of an odd shape like this, but I do know how to find the area of a rectangle. So let's come up with a couple rectangles. This is a range of 6 units. This is 6 squares wide. So I'm going to break this into 3 squares, which each have a width of 2. All right. And then I'm going to take the areas of these 3 rectangles put together, and that'll at least give me an estimate. And the way I'm going to think about the top of this rectangle is for the top of the rectangle, I'm going to let the upper left-hand corner of the rectangle meet the curve exactly. Okay, so these 3 rectangles are going to look like this. And if I take the area of these 3 rectangles, which I am able to do using my knowledge of functions and of geometry, it'll be at least an estimate. So the first thing I want you to do is I want you to pause the video and think about how these 3 rectangles can be used as an estimate. Do you think it's an overestimate or an underestimate of the area? And how good do you think it is? Okay, so let's think about what we're measuring here. So if we add these 3 rectangles together, we've got this shape and this pretty large shape over here that we're counting, that we shouldn't be counting. And over here on this side, we've got this area that we're not counting that we should be counting. So these are 3 pretty big regions here. So this isn't going to be a super estimate at all. But, at least it'll be in the ballpark. There's certainly much more that we are counting that should be counting. So this will be at least, not a ridiculous estimate. And it looks to me that the areas that we're counting but shouldn't be counting is much bigger than the other. So I think this is going to be an overestimate. Okay, now let's see how we can calculate the area of these 3 rectangles. So what I want to do is I want to look at each one of these rectangles and I want to think about its base and height, because multiplying those 2 numbers together is going to give me the area of each one of these rectangles. So the width of each of these rectangles is 2. That part's pretty easy. And the height, we could count and maybe estimate here, or we could look at our table, which I'm going to pull out in a few seconds. But what I want to do is I want to express these heights in terms of f. Okay, so for instance, the height of this rectangle, since the upper left-hand corner is meeting the curve, and the x value at that point is 1, I could say that the height of this first rectangle is f of 1. Okay, you see how this is? So when I look at 1, the height here is f of 1, and that's exactly the height of this rectangle. In the same way, this rectangle has height f of 3, and this rectangle has height f of 5. Excuse me. So that's enough information right here to come up with our estimate. Okay, so I'll bring up this. So the estimated area is, okay, so this rectangle is 2 times f of 1. And the second rectangle is 2f of 3. And the third rectangle is 2f of 5. And maybe what I'll do is I'll pull out this common term of 2 and just write it like this: f of 1 plus f of 3 plus f of 5. In a previous video, I came up with this table here, and I advised you to take a screenshot of that, so that might help you to pull it out. And so let me calculate this. So f of 1 is 6.67 to 2 decimal places, and f3 is 8, and f of 5 is 6.67. And I need to multiply this by 2, and so that gives me an estimated area of 42.68. So that's how big the sum of these three rectangles are. So that's at least an estimate of what the area under the curve is. What I'm going to call this is I'm going to call this a left-hand Riemann sum. Okay, and this is called a left hand because we're using the upper left corner of the rectangle to determine the height of the rectangles I'm using as an estimate. Riemann is named in honor of Bernhard Riemann, who is a German mathematician who really did a lot of work in really formalizing this notion of using calculus to take areas, and sum because we're adding up a bunch of rectangles. So we're using this Riemann sum to estimate the area under a curve. So that's a fairly good estimate. What we're going to do in the next video is we're going to do this same step except with more rectangles, and we're going to figure out for ourselves whether or not it's a better estimate, and we're going to calculate what that is, and maybe we'll see the pattern for calculating left-hand Riemann sums.